Hey folks, so this is going to be section 8.7, and I'd like to work on the secant and the cosecant parent graphs. Let's start with secant. In order to get your secant parent, you have to remember what the cosine graph looks like. So let's get the 5 major values, the highs, the lows, the x-intercepts from our cosine graph, and then we'll take that and use it to get our secant graph. So think about the highs and the lows of cosine. Cosine high and low was at 1 and -1. And I'm doing this in a very pale color, and I'll come back and use a brighter color when I actually graph the secant graph. So let's go ahead then and get the x-axis coordinates as well. We know that the end is going to be at 2 pi. The middle will be at pi. The first quarter point will be at pi over 2, and we'll count 1 pi over 2, 2 pi over 2, 3 pi over 2, and 4 pi over 2, just like we did back in section 8.6. Now for cosine, remember that cosine, the parent, begins at the maximum. I'm just going to put x's for my parent cosine because remember, I'm actually trying to graph secant. I'm not trying to graph cosine. I'm just going to use cosine. So there's my maximum there. And the next coordinate is going to be on the x-axis. My middle value is the minimum. Back to the x-axis. And then at 2 pi, I'm back to the maximum. And you can actually see, I'll draw it, but I'm going to erase it, so don't draw this on your notes. You can actually see where my cosine graph would be here. But we don't want cosine. Remember that secant is the same thing as 1 divided by cosine of x. Well, what number causes problems when it's in the bottom of a fraction? We know that if 0 is on bottom of a fraction, that this causes an undefined place. Now, I don't know if you remember this or not from Math 110, but the way that you draw an undefined place is by using an asymptote. So look at the places on your graph where cosine is equal to 0. We see that that happens twice. It happens once at pi over 2, and it happens at 3 pi over 2. These are my x-intercepts. That's where cosine equals 0. So these are the places where my secant graph is going to have an asymptote. So let's do this in a color. Anytime my cosine crosses the x-axis, my secant will have an asymptote, and you draw an asymptote using a dashed line. So let me say that again. If cosine crosses the x-axis, I'll write this down for you. Cosine crosses x-axis. Secant has an asymptote. Asymptote has a funny spelling. Okay? Next, I'm just going to give you the next few pieces here. Notice that my cosine maximum is right here at the beginning. This is my cosine maximum. My cosine maximum will become my secant minimum. Cosine maximum will become my secant minimum. So we remember that I'm going to draw this, but I'm going to come back and erase it. This was the beginning of my cosine graph. I actually need to flip that over to get my secant graph. So let me erase that part of the cosine. My secant graph is going to be going up from that cosine max. An asymptote is something you're always getting closer and closer and closer and closer to, but you never actually reach it. So here I can see that my cosine max became my secant min. The cosine max became my secant min. Now let's go to the portion between the two asymptotes. Notice this is a cosine minimum. Cosine minimum. My cosine minimum is going to become a secant maximum. Cosine min becomes a secant max. Lastly, we have one more cosine maximum, which is now going to be a secant minimum. Again, make sure that you're getting closer and closer and closer to asymptotes, but you never actually reach the asymptote. So all that's graphed in green then is my secant parent. Now let's go and do the exact same thing for the cosecant. So I'll go back to a gray color. For cosecant, we're going to be using the sine graph. So again, let's mark 1 and -1 on the y-axis. Let's go all the way to the end and mark 2 pi. Halfway is pi. Half of that is pi over 2, and then we can count 1/2, 2/2, 3/2, and 4/2. And let's mark our 5 major sine values. We know that sine begins at the origin, then it goes to a maximum at pi over 2, back to the x-axis for pi, minimum for 3 pi over 2, x-axis for 2 pi. Let's use the same concepts that we used for secant. Anytime sine touches the x-axis, cosecant will have an asymptote. So sine x-axis will become a cosecant asymptote. So that means, let's change over to a color again. My first time the sine touches the x-axis is right here on the y-axis. So that's my first asymptote. My second asymptote is at pi. My last asymptote is at 2 pi. Just like before, my sine max will become my cosecant min. So you see I have a sine max over here at pi over 2. It's going to become my cosecant minimum. Always getting closer and closer and closer to those asymptotes, never actually reaching them. My sine minimum will become my cosecant max. So here we have sine min. It'll be the top of this piece of my cosecant graph. And there you have secant and cosecant parents.